Do you like Booleans? Yes or no? I personally find myself somewhere between, which I guess means I don't like Booleans that much. Today I want to talk a bit about that. I find that when I use Booleans in my applications, in particular in data that I am storing, that it is not necessarily the right thing. And I find myself moving off of Boolean more than I find myself happy that I chose it in the first place. I have a lot of thoughts about this, and we're going to be touching on everything from the chaos that is Enums in many different languages, to database architecture and design, to how you maintain code bases at large team sizes and scales. I've been through it, and it's kind of funny that something as simple as a Boolean can be so complex once you get to these scales, but it can be. And there's a lot to dive into here, and I'm very excited to do that. All of that said, the monetization Boolean is set to true on this video, so we're going to have a quick word from today's sponsor, and then we'll dive into all the details. If you don't have users, you can skip this part. But if you do, and you feel like you don't understand them well enough, listen up, because Embrace is going to change how well you understand those users. I feel like most observability platforms are way too focused on errors. Spoiler, most of the errors on my services are people using weird Chrome extensions. Cool, really good. But how likely is a user to get through the onboarding flow? When a user tries a specific AI model, how likely are they to come back to the service? How good are our funnels for keeping our users? That's data that should be in observability, but isn't, because observability tools are focused on performance and crashes and almost nothing else, except for Embrace, because these guys come from the mobile dev world. They've spent the last couple years building the best observability tools for mobile, which care a lot more about the experience of using the app than they do about just giving you traces on errors. And they've brought that expertise to the web, which is really important because the web is becoming an application platform more and more every day. We spend our time in applications built for the web, either through the browser or through Electron. And now there's a platform so you can actually see what people are doing when they use your stuff. This is what we're talking about here, a chart that tells you completions, errors, abandons, and session volume. This is data that you can get from other places, but in a chart that's actually useful, good luck. God, it's so nice having observability into how completions change over time. This is the screenshot that made me embrace, pun intended. Seriously though, if you have a process with multiple steps and you want to see what step users are failing at, here you go. It's so useful for tracking how users are actually experiencing your stuff. Your devs deserve better than error reports, and your users deserve better too. Get the data you need today at soydev.link/embrace. I'm excited about this one. I have not found myself using Booleans on like server-side code or in databases for a while. Obviously, they're still nice on client for a lot of different things, but I'm very curious about this article. Huge shout out to Nicole for writing it, by the way. I have a feeling I'm going to love this one. That Boolean should probably be something else. One of the first types we learn about is the Boolean. It's pretty natural to use because Boolean logic underpins much of modern computing. And yet, it's one of the types that we should probably be using a lot less of. In almost every single instance where you use a Boolean, it should be something else. Bold statement. Let's see where this goes. The trick is figuring out what something else is. Doing this is worth the effort. It tells you a lot about your system, and it will improve your design, even if you do end up using a Boolean in the end. There are a few possible types that come up often, hiding as Booleans. Let's take a look at each of these, as well as the case where using a Boolean does make sense. This isn't exhaustive. There are surely other types that can make sense too. The date time, I was wondering if we'd get into date times quickly. That was going to be my first example. A lot of Boolean data is representing a temporal event having happened. For example, websites often have you confirm your email. This may be stored as a Boolean column, is confirmed, in the database, which makes a lot of sense. But you're throwing away data, which is when the confirmation happened. And this is a common one I'll see, is somebody at some point realizes knowing this data is important. So we have has confirmed true, and then confirmed at some timestamp. I can't tell you how many times I've seen this in a code base. And now when you have a function that marks confirmation as true, you need to make sure you hit both of these fields. And if you have this confirmation update in multiple places, there's a good chance that some of those places miss it. So what you end up with is in one place, the timestamp gets set, another place it doesn't, and now you have users that have has confirmed true, but don't have the confirmed at set. You've now done what I call a split brain. I talk about split brain a lot in my software design discussions. When I'm saying split brain, what I mean is that data exists in two different places that is coupled in some way. In this case, if someone has confirmed, then they have a confirmed at date. And if they haven't confirmed, they don't have a confirmed at date. You're encoding the same data twice here. but one of these pieces of data is higher resolution than the other. The confirmed at date tells you both that they have confirmed and when they confirmed. So you don't need the has confirmed field anymore. I would argue having it in the first place is a mistake because you don't want to have the data in two places when you can infer it from one. Generally speaking, when you can derive data, you should do that instead of storing the data. And if you need a cache, the cache should occur as close to where the client is or where the consumer is as possible. If you can avoid it, you shouldn't be caching by putting a field in your database next to another field in your database. And this is just one of the easiest examples to see that in. Great start. Maybe you find out down the road that there was a bug in your confirmation process. You can use the timestamp to check which users would have been affected based on the time when their confirmation was stored. You'll be amazed how often you'll end up wishing you had this. And the alternative is you go comb through all your logs and analytics to try and find all of the logs, if you even have them, for when the confirmations actually changed. I've been there. It's not fun. Just store it as a date time. I saw somebody saying that this is usually done because of indexing and fast query responses. No. You can just as easily index on date time as you can on a Boolean. And you also can now sort by the date time as well when you index on that. And I'm not saying that it should always be a timestamp. I'm saying it should be timestamp or undefined. It should be nullable. Because then if it's null, you know they haven't confirmed. And if it isn't null, you know they have confirmed. Very easy to index on. Next, we have enums. Oh boy. Much of the remaining Boolean data indicates either what type something is or its status. Is a user an admin or not? Check the isAdmin column. Did the job fail? Check the failed column. Is the user allowed to take this action? Return a Boolean for that. Yes or no? These usually make more sense as an enum. I absolutely agree. I cannot tell you how many times I've seen an utter mess along the lines of like completed Boolean, failed Boolean, in progress Boolean. This one is particularly fun because what ends up happening is there will be some bad partial case where when something fails, it will update failed to true, but it will forget to update in progress, and complete will still be false. And then if you have a check somewhere in your client code that checks in progress or completed, or even checks both, but doesn't check failed properly, you now see a loading spinner when the thing's actually failed. Oh God, chat, you're triggering me. Is active Boolean, is inactive Boolean? In my opinion, conflicting states should be represented in a way where they cannot overlap. If completed and failed can't be true at the same time, then your data architecture should not allow them to be. If in progress and completed can't be true at the same time, then your architecture should not allow them to be. In an ideal world, this would be status. And the status can be one of these many different values. Be failed, or completed, or in progress. And this also makes things way more extensible because you can check everywhere the status is being consumed. And if you add a new status or remove a status, you can make sure the client code handles it. And if you're working in a type-safe system, this can be even more powerful. The part where this starts to get a bit annoying, though, is if you also want to know when this happened. You can have a last updated, but if the last updated is for the whole field and not just for the status, that could be not good. But if you were to break this off to a sub-object like status, what would you even call the substatus of status? I like state for that. Good call. Now, since this is a subfield, it's much more likely that you as the developer or other people on your team will update both at the same time. You get the idea though. And when I say subfield, I don't mean that like this should be a JSON object in your DB. It could be a separate table that you are joining against. It could be a lot of other different things, but ideally, if you need both of these values, you would encode it accordingly because the alternative is completed at, failed at, in progress, started at, not great at all. And as always, your needs might differ. In my opinion, relatively valid structure for this would be something like this. So you have your status, but you also have started at, because you might want that for many reasons, and finished at, which you would have for lots of different reasons. Now you can infer from status and started and finished at some amount what happened. So if it's completed and it has started and finished at times, you know how long it took. If it's failed and it started and finished at, you know how long it took until it failed. You can derive all the other states you might want from these pieces of information. But the common mistake I see, and I see this a lot, because they want when a job failed, they'll update the DB to have failed at. Obvious intuition. They want to show in the UI when the job failed. They want that information, so they put failed at in the DB. But they could also infer that from other things. If they see status failed and they see finished at some time, you can infer when a job failed from that. But if you go from what data you want and storing it in the database, you'll end up with some really bad architecture. But if you think about how you get the data you want and what shape of data makes the most sense to store for flexibility in the future, you can get the data you want at the end. Whether or not we want it to be, all data is kind of a graph. All things come from other things. And from this structure, we can find a lot of stuff. From here, we can figure out the duration. From here, we can figure out when it failed. From here, we can figure out current status. From here, we can figure out how long does it take for a job to fail on average. These are all bits of information that we can infer from here. And some of them are chained. Like we know duration, we know when it failed, and we can use those pieces of information to figure out how long does it take for a job to fail on average. This is what you get when you architect your data correctly. But if you had just stored duration in there, if you had stored the failed Boolean, or you had just stored finished at and not started at, you might be missing bits of information. But if you store the key pieces that occur through the design of your software, the thing you get on the other end is really good. Data normalization is the key concept I'm trying to break down into dumber, easier to understand language here. The idea is that the database's constraints are able to enforce the expected states the data can be in. And even here, there's a little bit of breaking stuff, because you could have finished at be a value even when the status is in progress, because you can set that incorrectly. But it's significantly less likely than when you have the chaos I was showing up here of completed, completed at, failed, failed at. You get the idea. Big fan of enums, big fan of start and finish times. I will also argue, and I will fight this forever, pretty much every single database ever and every single table I've ever touched benefits some amount from having a created at and an updated at field. They're almost no data. They will come in clutch eventually. I just put created at and updated at on every single table, and it has saved my ass so many times. People see the convex mention coming in. Yeah, convex does this for you. Most ORMs will do this for you as well, thankfully. Just good design. Let's go back to the article because I'm loving this. User role is a really common one too. Like having is guest true, is user true, is paid user true, is admin true? No, like if these are conflicting, they should be an enum. If your keys can conflict, try to make them one key. I think that's a generally fair piece of advice. As they say, job status is another really common one here. You just have one single field status, which is an enum across the various statuses. Note, though, that you probably do want timestamp fields for each of these events, but you're still best having the status stored explicitly as well. That is hilarious. I didn't pre-read this. Same conclusions. This begins to resemble a state machine. Speak in my language. Whether or not you want to accept it, your database very quickly does become a state machine. Another really good point from chat. This is Jay Gold, who works at Graphite. Enums are great, but we like using strings and then enforcing them with Zod at runtime because that means less migrations and the risk is pretty low. I absolutely agree. Enums in general are, especially in TypeScript, it's a bit of a weird thing. The state of enums in TypeScript is rough. But if you think of it like an enum and you have a strict type and a Zod validator for the input and output, you're good to go. The only risk there is if you remove something from that, your database migration isn't even a migration, and now you have data that will fail your validator. But small pieces, big puzzle, you get the idea. This isn't just for storing in a database either. If you're checking a user's permissions, you often return a Boolean for that. So check permissions, user, bool, false. No one's allowed to do anything, I guess. This is great. In this case, true means the user can do it, and false means they can't. Usually, I think. But you can really start to have doubts here, and with any Boolean, because the application logic meaning of the value cannot be inferred from the type. Instead, this can be represented as an enum, even when there are just two choices, allowed and not permitted. As a bonus, though, if you use an enum, you can end up with richer information, like returning a reason for a permission check failing, and you are safe for future expansions of the enum, just like with roles. Funny enough, God, I'm going to try to not fall for what will become a very, very big tangent. This is why I don't like role level security and why I don't like things like Firebase and Supabase. Because permissions isn't just state. It's not something that can just be stored. The role of a database is to store data. Permissions aren't data, they're logic. Permissions are derived from the data, but they aren't the data, they're permissions. This is why I like Convex and don't like Firebase and Supabase as much. Because Firebase and Supabase have you store what a user can do as part of the data structure. The database has a concept of these rows can be accessed by this user because this field has their user ID in it. And someone just dropped the sign, my favorite diagram I've ever drawn. And remember, I'm not anti-GraphQL. I am, generally speaking, relatively pro-GraphQL compared to most people nowadays. But the GraphQL should not go between the server and the database. It should go between the server and the user and client. GraphQL goes between those two, not between the database and the server, because now you have given up the ability to write code to define that logic. Row-level security is logic, and it was written by somebody. Code is running, but the code that is running is not yours, and it is way too easy to gloss over what has what permissions. And you'll end up in weird states all of the time. A ton of the recent security issues that we've been seeing in things come from people not configuring the permissions properly in Firebase and Supabase. There are whole crews of hackers that just look for sites that are using those two backends because there's such a high chance that they've configured it wrong because they're not configuring it with code. Permissions are logic, and if your data is structured properly, your logic shouldn't be in the data. Your logic should be the thing that takes the data and makes a decision based on it. I absolutely agree with the author here so far. How about conditionals? When should we use a Boolean? I've mainly run into one case where it makes sense. When you're temporarily storing the result of a conditional expression for evaluation. This is in some ways an optimization, either for the computer, reusing a variable, or for the programmer, making it comprehensible by giving a name to a big conditional, by storing an intermediate value. Here's a tried example where we use a Boolean as an intermediate value. I can't tell you how often this is the comment I leave in code reviews, that there is a giant ternary or like nested Boolean somewhere that's just dropped in an if statement and I have no idea what it is or what it does. Just pop it out and give it a name. It makes life so much easier. This would be some nice long conditional, but I don't have one, so variables it is. Let user can do this, A and B, and C or not D. That's great. I would break this down even further. So we have these variables now. Even here, I would break things down a bit more. I would have const is A and B. Const is C or not D equals C or not D. And then there you go. It's not meaningfully more code, but it makes this meaningfully more readable, especially if A, B, C, and D are specific things. You get the idea. I like really explicit code. I am known for writing variable names that are like 4 to 5 words long, because who cares? It gets compiled out anyways. It just makes it easier to read the code. And all our shit autocompletes anyways. You're not typing that out every time. Naming shit's not as hard as developers seem to pretend it is. I might be biased because I'm as much a marketer as a developer nowadays, but just describe the thing. I say as the creator of upload thing, marker thing, and webhook thing, and pick thing. You get the idea. Just name the thing what it is. But even in this contrived example, some enums would make more sense. I'd keep the Boolean probably, simply to give a name to what we're calculating, but the rest of it should be a match on an enum. Yeah, I agree. That's another thing I do a lot. Instead of defining all of this that way, this is something I'll do a lot. I regularly ask in code review for my team to break out some random check like this into a function, not because it's more efficient or anything. It's not. Like spinning up another event isn't necessarily a good thing. But what is good about this is it gives a very explicit, can user do this? You now have a name for the thing. You can leave comments on it. You can make changes to it and have different places break. It makes things really clear. I'd say half the functions I write are something like this, where instead of just doing a giant if check in the code, I write something like that instead. I also find myself using this more often than even switch statements nowadays, because you can just early return and skip a lot of the value from the switch. And you get the idea. Sure, not every Boolean should go away. There's probably no single rule in software design that's always true. Let's think of one. What's a rule that's always true? Don't date your manager's wife. Not false is always true. True is always true as well. While true is definitely always true. It's true for too long even. I think mine that's always true in software is that developers care too much. You never know what it is they care too much about, but they care too much about something. Booleans are sneaky. They feel like they make sense for our data, but they make sense for our logic. Ooh, I love this distinction. This is kind of the permissions thing too. Permissions are logic, not data. Booleans are very logic driven. They're not good state, they're good logic. And as part of your logic, there are a lot of Booleans that will come out, but that doesn't mean you should stuff them in the DB as a Boolean. It just means that your code is taking the data and converting it into stuff that you can use. But Booleans are a part of a logical set of checks. They aren't necessarily something that belongs in good data architecture. As the author says, the data is usually something different underneath. By storing a Boolean as our data, we're coupling that data tightly to our application logic. Woo, bangers. Again, the diagram I drew before. If this is what you want, it's very easy to just add that in. Or if it was if a job failed, it's very easy to go stick the result of that if statement of true or false. But we don't want that in our database. We want to be able to get that from our database. We want our logic to be able to get the info we want. We want the database to represent the data that we know. Instead, we should remain critical and ask what data the Booleans depend on, and should we maybe store that instead? It comes easier with practice. Really, all good design does. A little thinking up front can save you a lot of time in the long run. I absolutely agree. This was an awesome article. Shout out to Nicole for writing this one. If you're looking for coaching services from an experienced developer, I am far too busy. Appears that they are not. There's a link there if you're interested. Good stuff. Thank you, Nicole, for writing this. As always, links are in the description. Great article, great content. If I had to rate this on a scale of 0 to 1, it's absolutely getting a 1. Until next time, peace, nerds.